Hey there, this is MathCamp321 presenting a lesson on writing the explicit definitions of both arithmetic and geometric sequences when you're given two terms of the sequence. So in number 6, and if you have your packet out, I'd like you to fill this out as you watch this. It says write the explicit definitions A if C sub n is arithmetic, and B if C sub n is geometric, if C sub 2 is 3, and C sub 5 is 24. So we've got some sequence out there, and the second term is 3, and the fifth term is 24. And I'm going to first approach this problem as though the sequence were arithmetic. So I'm going to start by just writing the general explicit formula for an arithmetic sequence. So I've written down the general formula for an arithmetic sequence, and now what I'm going to do is I'm going to write down two equations based on the two given pieces of information. So the first one is that the second term is 3. So the second term, which we're going to call C sub 2, is equal to 3. And then we're going to plug in as much of this as we know. The first term of the sequence I don't know. They give us the second term and they give us the fifth term, but we don't know the first term. So I'm going to leave this alone. Now, I'm defining n to be the number 2. So this is going to become 2 minus 1. And the common difference, or the space between successive terms, is unknown, so I'm going to leave that as d. Now I'm going to develop a second equation based on the second piece of information, which is that the fifth term is equal to 24. And I'll plug as much of this information into the master formula as I can. I still don't know the first term. I'm now letting C equal 5, which means this becomes 5 minus 1. And I still don't know what D is, the common difference between successive terms. So what I'm going to do now is I'm going to create a system of equations based on these results right here that I'm going to put a purple box around. So I'm going to write these again, but I'm going to clean them up at the same time. I'm going to say C sub 1 plus D is equal to 3. And I'm going to say C sub 1 plus 4D is equal to 24. And as you may have spotted, we have a system of equations here. And this system is pretty easy to work with because if I just subtract one row from the other, the C sub 1s are going to drop out. And if I do that, I'm left with negative 3D is equal to negative 21, which means that D is equal to 7. And now that I know that D is equal to 7, I can back substitute and figure out what C sub 1 is going to be. So maybe I could back substitute into that. So I'll say C sub 1 plus 7 is equal to 3, which means that C sub 1 is equal to negative 4. With these two pieces of information, I'll be able to construct the explicit definition for this particular sequence. And I'll start by saying C sub n is equal to C sub 1, which is negative 4, plus n minus 1 times D, and D is 7. Cleaning this up a little bit, I get C sub n is equal to negative 4 plus 7n minus 7, or C sub n is equal to negative 11 plus 7n. So this is the explicit definition, or the formula, which will give me or generate any term on this sequence. Now we're going to do part B, which is considering the same initial set of information, but thinking about it as though it's a geometric sequence. So I'm going to start with just the general definition of a geometric sequence, which is that C sub n is equal to C sub 1 times r to the n minus 1. And I'm going to keep that formula at my fingertips as I plug in some of the very specific information. So the second term is 3. So I'm going to say that C sub 2 is equal to 3. I don't know what the first term is. I don't know what the common ratio is, but I am saying that C is equal to 2 So this is going to become 2 minus 1. And now I'm going to go to the second piece of information, which is that the fifth term is equal to 24. I still don't know what the first term is. I don't know what the common ratio is, but I am letting c equal 5, which means this becomes 5 minus 1. And what I notice here is that I have another system of equations, but this one's not really quite the type that we've ever seen before. This one involves multiplication. To solve it is not so difficult, but it is a little bit different. So I'm going to do a little bit of cleanup here and say c sub 1 times r is equal to 3, and then c sub 1 times r to the fourth is equal to 24. So here's my system. I'm going to draw a line underneath, and this time I'm going to divide, but I'm going to divide upwards, which is a little bit strange, but there's a reason that I do that. So I want you to read this from bottom to top. So c sub 1 divided by c sub 1, well, anything divided by itself just goes away. What about r to the fourth over r? If you just saw r to the fourth over r, what would you say that that is? Well, if you said r cubed, you're correct. And then 24 divided by 3 is 8. Now I'll take the cube root of both sides, and I get that r is equal to 2. Now I can back substitute and solve for c sub 1. I think I'll go back to this first equation because it was pretty basic. So c sub 1 times 2 is equal to 3, which means that our first term is equal to 3 halves. And now I can generate the specific formula, the specific explicit formula for this sequence. So any term can be found by using the first term, which is 3 halves, times r, which is 2, to the n minus 1. So this is a very standard type of question that I've seen both in textbooks and on the SAT-2, where they give you a sequence and they give you a couple terms on the sequence, and you have to sort of work backwards with the formula to come up with the explicit definition. So we involved systems of equations. One was a more traditional one using addition and subtraction, and then in part B we saw one that involved multiplication and division.